So I think we got all the, um, we're clear on this, but I just want to make, uh, double sure that we're clear on this, because, you know, the next homework assignment that's due, Monday, right, involves this. I'm trying to get some chalk, the right piece of chalk. And so, limits that exist, right, equal a number. So we have the limit of the function f of x as x equals a, right? It might equal a number, right? It's some real number, right? It doesn't have to be 5, it can be any real number. But when this is the case, right, we say the limit exists, okay? When we have a function that like contains a vertical asymptote, right? If the vertical, so on each side of the vertical asymptote, right, the function blows up. Yes, sir?
It's still 2.3.
This is 2.2.
Okay.
Right. So we talked about this last week on Thursday, and I've been meaning to and then it was brought to my attention on Monday that I may not have been the clearest in talking about this. Okay. So and so I was going to talk to you about it on Wednesday, but I forgot to upload that or print out that little document. So now today's Thursday, so it's taking me 7 days or 4 days, 3 days since Monday. But so here's x equals a, okay, and so the closer x is to a, right, the larger the value of the function is. Okay. It increased the value of the function is increasing without bound. And so the limit in this case is limit f of x as x approaches a, technically speaking, does not exist because the limit does not equal a number. Okay. But to indicate the behavior of the function, the behavior of the graph, since both sides are going up, okay, the value of the function is increasing without bound, we write plus infinity. Okay. And so you'll often hear me say something like the limit of f of x as x approaches a is equal to plus infinity. Right? But technically the limit doesn't exist. Okay. It means the value of the function is increasing without bound the closer x is to a. Okay. And then you got the other scenario where the graph goes down on both sides of the vertical asymptote, right? The value of the function is decreasing without bound the closer x is to a. And so in that case, the limit doesn't exist as well, okay? But we write minus infinity to indicate the graph is going down, okay? That the function is decreasing without limit, okay, without bound. And then you have the third scenario, where the graph goes up on one side and it goes down on the other, okay? And since the left-hand limit is plus infinity and the right-hand limit is minus infinity, right? Then we write the limit of f of x as x approaches a does not exist, okay? Now, if we were just doing left-hand and right-hand limits over here, we would write the limit as x approaches a from the left of f of x is plus infinity, right? Because we're just dealing with values of x less than a, right? So for values of x less than a, the graph is going up. And for values of x greater than a, the limit of f of x as x approaches a from the right, we would write is equal to minus infinity.
Those limits still don't technically exist.
They don't exist because it's not equal to a number, right? It's got to equal a real number. Okay.
We had a quizzer test and it asked us to state the limit, and we had the situation where we still say that.
In fact, you're going to have it on the web-assigned homework.
Yeah,
right?
Yeah, the homework, I know that's the solution,
Yeah.
but I'm just asking.
And so actually on the test or quiz, it'll say when it comes to evaluated limit, either write a real number, minus infinity, plus infinity, or does not exist. Okay? So technically speaking, does not, in this case here, does not exist is a correct answer, but we want more than just a correct answer. Okay? We want to know the direction of the behavior. And it'll say that right in the instructions. Yes, ma'am.
Can you draw like the graph that would be like the function equals 5 where the limit does exist? Or is that picture the graph right below?
No, so you want to see a picture where the
Yeah.
limit is equal to 5?
Yeah.
Sure. So 5 is the y coordinate, okay? And so a, right, it's just some value on the x-axis, right? So we can have either a hole here, right? So at x equals a, y equals 5. We can have a hole there or closed circle. Doesn't matter, does it? It's just got the limit from the left, from the right, and the limit from the left have to be the same. Okay? So this is the ordered pair A5. Okay? And in my picture here, okay, instead of a closed circle, I have an open circle. Okay? It doesn't have to be continuous at that point, right? And so the left-hand limit as A approaches 5 from the left, the left-hand limit is equal to 5, and the limit is the limit as x approaches A from the left, the limit is equal to 5, and the limit as x approaches A from the right, the limit is also equal to 5. So that's an example where it exists. Okay. Any other questions, ladies and gentlemen? Okay. So don't worry. You know, we'll have it all straightened out by the exam. Okay, that's what's important. Okay. Calculus is like learning lots of topics you've never learned before, right? I mean, you've done algebra, high school, did college, and maybe college algebra, and I did pre-calculus, right? But calculus is sort of a